So good morning. Welcome back to the part 2 of lecture velocity in mechanism using relative velocity method. So we'll try to solve some problems. Okay. So in a 4-bar chain ABCD, AD is fixed and is 150 mm long. The crank AB is 40 mm long and rotates at 120 rpm clockwise. While the length CD is 80 mm and it oscillates about D. So BC and AD are of equal length and the length is given as 1. So you have to find out what is the angular velocity of the CD when the angle BAD is 60. So first you have to draw the space diagram with the given data. So you first draw AD 150 mm long. Next, mark the crank AB, which is making an angle of 60 and of length 40 mm. Now we know BC is equal to 150 and DC is equal to 80. So using a compass with B as center, draw an arc for 150 and with D as center, draw an arc of radius 80. So these two arcs will intersect and we will be getting the point C. Now we are going to draw the velocity of the mechanism. Now we have the points A and D as fixed. So since the points A and D are fixed, you can represent the link AD by a single point as A, D. So whenever we are finding out the velocity with respect to the point A or to the point B, it is called as absolute velocity because those 2 points are stationary. So velocity of B with respect to A is also equal to velocity of B because the A point is stationary. So it can be called as absolute velocity of the point B. So here you can see the link AB is rotating with respect to AD. So whenever a link is rotating, we saw that the velocity is tangential to the circle, or in otherwise it is perpendicular to the link. Correct? So this is the radius of the circle. அப்ப இதுக்கு tangential இருக்கு அப்படினா then it is perpendicular to the link AB. So you can see that velocity of B is perpendicular to AB. So if this is making an angle of 60 degree with the horizontal, then its perpendicular will have to make an angle of 30 with the horizontal. So from the point A, draw a line VB. If we have BB making an angle of 30 degree. Now to find out what is the length of VB, you have to find out what is the magnitude of VB vector. To find out the magnitude of the VB vector, we know that velocity of VB is equal to omega into length of the link. To find out omega, the speed is given. So speed is 120 rpm. So omega is 2 pi n by 60. From that you can find out what is omega. After finding out the omega, multiplying it by the length of the link AB, you get the velocity of B vector. So the length of the B vector is 0.503. Take a suitable scale to represent the velocity vector. So let us assume that 1 centimeter is equal to 0.1 meter per second. Then AB will be equal to 5 centimeter. So we know the magnitude as well as direction of velocity of B with respect to A. Now coming back to the point C, velocity of C point is going to rotate with respect, if you consider the link BC, if you are finding out the C point, it is going to rotate with respect to the point B. And if you are considering DC, again C point is going to rotate with respect to D. So you can see that velocity of B with respect to C will be perpendicular to the link BC. So you have the link BC here. You draw a perpendicular to the link. So this will be the direction of the perpendicular. Since the vector is from, so this is BC, so you draw a perpendicular. Okay, so this will be the perpendicular. So here you will have the perpendicular. So from the point B, you draw a line perpendicular to BC, that is representing the velocity of B with respect to C. Okay. So you draw a perpendicular. So velocity of C with respect to B. I am repeating once again. The link BC is going to rotate with respect to B. So velocity of C with respect to B will be perpendicular to BC. So you already know what is the point B. So if you draw a perpendicular to BC passing through B, then that will represent the velocity of CB. Similarly, velocity of, if you are considering the link DC, velocity of C with respect to D will be perpendicular to the link CD. So here you have the D point. So you drop a perpendicular to the link DC passing through A. So link DC க்கு perpendicular A இலிருந்து ஒரு line வரையிறீங்க. So these two links, so this is velocity of CD and this is velocity of CB, and those two vectors or those two lines will meet at a point, and that point will be the point C. So to measure, if you measure BC, that will give the magnitude of the velocity of C with respect to B. Similarly, if you measure CD, that will give the velocity of C with respect to D. So since it is velocity of C with respect to B, arrowhead should be directed towards C. And since velocity of C with respect to D, arrowhead should be directed towards D. So after finding out, you can measure it. If you measure, you can see that it is 0.385 meter per second. So you know that velocity of CD is equal to, you know what is the magnitude. You also know that velocity of CD is equal to omega CD into CD. So from that you can find out omega CD is equal to velocity of CD divided by CD, that is the length of the link CD. You can find out what is the angular velocity of the link CD. So let us discuss one more problem with a crank and a connecting rod. So the crank and the connecting rod of a theoretical steam engine are 0.5 and 2 meter long respectively. The crank makes 180 rpm in the clockwise direction. So from this you can find out what is the angular velocity of the crank, that is 2 pi n by 60. So it has moved or turned an angle of 45 degree from the inner dead center. So the crank is making an angle theta of 45. So you have to find out what is the velocity of the piston, angular velocity of the connecting rod, velocity of a point E on the connecting rod, 1.5 meter from the gudgeon pin. So gudgeon pin is the pin which connects the piston with the connecting rod. Okay, so it is also called the wrist pin or the small end. And next you have to find out what is the rubbing velocity of rubbing at the pins of the crankshaft, crank and crosshead. when the diameter of their pins are 50 mm, 60 mm and 30 mm respectively. So first of all, we are going to draw the space diagram given with the given data. So you have to know that the crank is making an angle of 45. First draw a straight line, make an angle of 45, measure and mark OB which is equal to the length of the crank 0.5. From the point B, take 2 meter as radius. You have to take this to some scale. Okay. So take 2 meters. So if 0.5 meter is equal to, say here you take it as 2 meters, then this has to be proportionally taken. Okay. So with B as center, you take the radius and cut the point B. Now if you join these, you will be getting the space diagram of the slider crank mechanism. So after finding out the space diagram, you have to find out what is the velocity of OB. So this is one data where if I know the magnitude of the velocity vector as well as the direction of the velocity vector. So this is moving in the clockwise direction, I suppose. So it will be moving in this direction, vector will be in this direction. So velocity of VB vector is equal to, or velocity of B point with respect to O is equal to omega OB into OB. So you know what is OB? Length, that is 0.5. You know what is the angular velocity. So from that you can find out what is velocity of the point B. So here again O point is stationary. You know what is the magnitude as well as the direction. So since this is making an angle of 45 with the horizontal, then its perpendicular should also make an angle of 45. So clockwise, so you know the direction also, it is directed outwards. So here you mark OB of that represents the velocity of B with respect to O, and magnitude is 9.426. Now next is you have to find out the point B. So the point P is going to oscillate about the point B. So velocity of P with respect to O will be perpendicular to the link PO. So if you draw a perpendicular, that will give the direction of the velocity of P with respect to OB, or you can say that of the connecting rod. So this is, you have to find out. So for that you can find out the angle, or from the space diagram you can find it out. Okay. Both the ways will be the same. So if you want to find out the angle, you drop a perpendicular and find out what is this angle and this angle, and then you can find out what is the angle made with respect to the horizontal. Okay. So you draw a line perpendicular to OB and you measure what is the angle made with the horizontal. So the same you have to mark it here. So this will be the PB line, which is the velocity of the point B with respect to B. Now if you measure this will give the velocity of the connecting rod. So if you measure PB, that will give the velocity of the connecting rod. And if you measure this OP, that will give the velocity of the piston, because P represents the piston and O is the stationary point. So PO, that is velocity of P with respect to O, is nothing but velocity of the piston. So if you measure this, you can find out what is the velocity. So since it is P with respect to O, arrowhead will be directed towards B. Similarly, here you can see B with respect to P, therefore arrowhead will be directed towards B. So if you want to find out any intermediate point, what you have to do is, you find out the ratio at which the point divides the link. Suppose it is dividing in the ratio of 1:3, Again you have to fix the point